This is for lesson 11 and the cool down called Features of a Graph. So, key concepts. We've got two different situations here. One with May and a bus pass and stuff, and the other one with a student club raising money. The key ideas here is we want to be able to see the relationship between what the situation is and the equation, and then how that equation translates into what we see in the graph. So, first of all, May receives a $40 bus pass each school day. She spends $2.50 to travel to and from school. If D is the number of school days since May receives a pass and B the balance or dollar amount remaining on the pass, we have this relationship. If B is her balance, she starts with $40 and she takes away or loses or spends $2.50 every day. So we take 40 minus 250 times the number of days that she's traveling on the bus. Now, this right here is slope-intercept form. Kind of. Slope-intercept form, the way we normally talk about it is y equals mx plus b, where m is your slope or your rate of change, and b is your y-intercept. But the order here does not matter. As long as we're looking at the number in front of the variable as your slope and the number with no variable as your y-intercept, you'll be fine. So if you take a look at this, the number that doesn't have a variable is our y-intercept, which we can clearly see over here. Now that makes sense, because if this is the number of dollars that she has and this is the number of days, obviously, if she starts with $40, we would expect that the amount of money that she has at day 0 is $40. Now, the slope we can see in our graph in terms of the change in y divided by change in x. And it can be from any point to any point. So I'm going to look at the change in y divided by change in x from that point to that point. So if we take a look at this, close enough. My change in y from this point down to this point, I'm going from 40 to 15. That's going down by 25. And then, looking at my change in x, I'm going from 0 to 10. That's a positive change of 10. So my slope, looking at my graph, is negative 25 over 10, which is negative 2.5. And if we look back at our equation, we can see that we've got that negative 2.50 right there. Now this second scenario here, situation 2, is a little bit different. Student club's raising money by selling popcorn and iced tea. The club is charging $3 per bag of popcorn and $1.50 per cup of iced tea and plans to make $60. The way that this is written naturally leads us to write something in standard form, because if we're looking for the total amount that we're going to make, $3 per bag of popcorn, we're going to take $3 times the number of bags of popcorn that are being sold. $1.50 per cup of iced tea, we're going to take $1.50 times the number of cups of tea. And if we combine those values together, we get our total. It's a little bit harder, though, to make the connection between this and this. There's two ways we can do that. The first way that we could do that is we can change this into slope-intercept form. So slope-intercept form is y equals mx plus b. We don't have an x and a y here. However, we have a horizontal and a vertical, and since y is usually the vertical, in this case we have cups of iced tea, what I want to do is I want to solve this equation for t. So looking at the equation, on the left side, I have 3p that I don't want there. And the way that we take something away in math is we subtract. So I'm going to take away 3p. Now, if I take away 3p from the left side, I got to take away 3p from the right side to maintain the balance of this equation. And I'm left with 1.50t equals 60 minus 3p. And then I want 1t, not 1.5t, so I'm going to divide both sides by 1.5. I'm going to divide everything by 1.5, and I'm just going to leave off the 0 because it doesn't matter. And what we get then is t equals, I believe it's 40. Yeah, it's 40 minus 2p. So, looking at our equation, I would expect to see a y-intercept of 40, which I see right there. And we should see a slope of -2. So let's check that out, actually. Slope of -2. So I'm going to go from this point down to that point this time. So my change in y, I'm going from 40 down to 20. So that's a change of -20. So I've got -20 over, well, my change in x, I'm going from 0 to 10. That's a change of +10. And -20 divided by 10 is -2. Hey, look at that. All right, so we can see we've got our y-intercept, 40. We've got our slope, -2, which we calculated. It's down 20 and over 10. So that's one way. The other way that we could also do this is we could ask ourselves, well, what would happen in a situation where we sold no popcorn or no tea? So if I sold 0 popcorn or 0 tea. If I don't sell any popcorn at all, P is 0, what would T have to be to get up to 60? Well, that would be 40. And then, what if I didn't sell any tea at all? How many popcorns would I have to sell to get $60? Well, if each popcorn is $3, 60 divided by 3 is 20. So I should see the point 0, 40 and 20, 0 on my graph, which I in fact do. So that's two different ways that you can do that. Now, consider the equation 1.5x plus 4.5y equals 18. For each equation, explain or show your reasoning. If we graph the equation, what is the slope of the graph? Well, it's asking about the slope. And hey, look at this. This is asking about where it intersects the y-axis. This naturally seems to be asking you to put it into slope-intercept form. I would do that. And then the question of where does it intersect the x-axis? Well, you remember when I had that chart with the p and the t where one was 0 and the other was 0? The y-intercept is where x is 0. The x-intercept is where y is 0. So you're going to kind of have to do both things that I asked you to do, or that we worked on over here. All right. I hope that helps. Sorry this was kind of a longer one. If you need any help, make sure you talk to me, talk to your teacher, reach out. We want to help you.